welcome back. This is Krishna and welcome to my YouTube channel, AI Martian. And I was creating videos on deep learning. So today we will talk about one hot encoding in the same sequence. So what happened in one hot encoding, why it is required, what are the agenda for today? I will show you everything in this video, okay? So we will go through Google Colab and I will explain each and everything with serial examples. So let's go to Google Colab sheet, guys. So we will talk about one hot encoding. This is the today's topic. Okay. So in this, we have like agenda explanation of one hot encoding. The second one is real-time example, and third one is alternate options, like what alternate option we have available to create one hot encode like TensorFlow. Okay. So the fourth agenda is execution comparison with other tools. Okay. The fifth one is conclusion, why it is required. So I'm just going to explain you each and everything one by one. So the first of all I have to show you is like explanation of one hot encoding. So here I mentioned a concept. Okay, I just googled it from somewhere. Okay, and I stick it here. Okay, so the explanation of one hot encoding is quite complicated, maybe it will look like, but don't worry, I will explain it with a suitable example. So let's see this. Here I mentioned one hot encoding is a technique used to convert categorical data, keep these things in mind. Okay, categorical data into binary matrix. The second keyword we have to keep in mind is binary matrix. So binary matrix representation, each category is represented by a vector of 0. So third keyword, vector, okay, of 0, 0, except for the index of the category, which is marked as 1. So we have 4 keywords available here, which we have to go through. We have to focus genuinely on this. So what it is talking about. So one hot encoding, I just want to give you an example. Okay, so that's why I mentioned here. So this definition, I will again explain you with a suitable example. So let's move to an example first of all. So I'm simply erasing everything. So I want to explain each and every term using example. So I'm picking one example. Suppose I have 3 fruits. First one is apple, banana, and cherry. I have 3 fruits. Okay. Now I have these 3 classes. Okay. Means I have a data set. I have a data set, let's say, a data set which contain features and target. So here I have 2 features. Okay, this is feature 1. I'm representing the feature by x1 and x2. Okay, so I have 2 feature, let's say, of each fruit which is available in this vector or list, you can say, having 2 feature each. Okay, and this is the target. I'm representing, let's say, target using y. Okay, so these 2 are feature and this is the target. Okay, I have this kind of data set available in my machine, okay, which I will pass to my machine learning model to train. So now let's say this is apple. Okay, this is banana. Okay, and this is, let's say, cherry. Okay, so we have 3 fruits. This is apple. Okay, this is banana, and this is cherry. Okay, so we have 3 fruits. Now what kind of feature available to me? So feature available to me are, suppose this is apple, so I have its width and its height. Okay, so this is the height. Okay, similarly in this case I have this height, you can say this is height. Okay, and This is, you can say, width. Okay. In cherry, I also have some width and some height. Okay. So in all this scenario, in all these three kind of fruit, if I will go with apple, let's say apple is quite bigger as compared to cherry. Cherry are smaller in shape, size, right? So width of apple, let's say something called 3 inches, okay, and height is like 2.5 inches, okay. Whereas in a banana, height is, let's say, uh, 10 inches, okay, 10 inches, and width is, let's say, 1 inch, okay. So similarly, I have like a width of cherry is 0.5 inch, and this is width, okay, and the height should be, let's say, 0.5 inch as well, okay, means about same, okay. So in these three fruits, I can differentiate each fruit on the basis of their width and height, okay. If, let's say, I have a width which is similar, let's say, I'm not saying exactly, it is a little bit, you can say similar, okay, similar to height, okay, and it is greater than, means width and height, let's say greater than 2 inches, okay, or we can say 1.5 inches, must be apple. We can see that, right? Because always whatever we see, like apple, their width and height always greater than 1.5, okay. Whereas in cherry, width is equal to, let's say, not exactly, okay, but approximately I'm talking, okay. So if it is less than 1.5 inches, that means that is cherry, okay. But how can we differentiate this? So we will simply say like length is, height and length both are same, okay. So I'm simply giving it a different name, height, okay, instead of length over here, okay. You can say height is greater than, let's say, 5 inches, okay, that's a banana, okay. And we have to keep in mind width is also important because this is a feature. So width should be like a width between 0.5 inches, okay, and less than 2 inches, I'm saying, let's say, okay. So this feature basically introduce or represent banana. So these kind of feature I have available in this table, okay, and their target. Suppose I'm getting here 3 inches, which is this, okay, and 2.5 is the height, okay. So this is simply apple, all right. Whereas I'm getting, let's say, a height is 10, okay, and not exactly a height, it is width, right? This is width column, and this is height column, okay, because I mentioned 3 in this column, so this is width, right? And here I have width like 1 inch, okay. So 1 I will mention width, okay, and the height should be, let's say, 10 because I mentioned here 10, and it would be banana, okay. Whereas in the third segment we have cherry, right? So cherry width is 0.5, okay, and their height is, let's say, 0.5 again, okay, and I'm mentioning it cherry, okay. Such kind of data set I got from internet, let's say, okay. So there in this data set I have more than 500 samples of each fruit, all right, all right. But the problem is, in my data set it is mentioned like apple, banana, and cherry. This is called categorical data. Categorical data. Now we already gone through this terminology in the definition of one hot encoding, which before this drawing, okay. So categorical data come in picture. Okay. So I have to basically pass this categorical data in the form of number. Okay. Why number? Because behind the scene, behind any machine learning model, there is a mathematical algorithm. Okay. So because of this mathematical algorithm, I have to convert this categorical means alphabetical data into numbers. Okay. And now you guys will think like it has a 500 sample of each classes, means how many classes, how many kind of fruit we have. So 3 fruit like apple, banana and cherry. So you guys will think, let's give them some number, okay, unique number of each classes. So wherever it is mentioned like apple, I will simply mention, let's say 0. Okay. Wherever it is mentioned banana, I will mention 1 there. Okay, in this column. Okay. Wherever it is mentioned cherry, I will mention 2, let's say. Okay. So I gave unique values to them, but there is some problem. Now what kind of problem? We gave number. Now machine learning will able to understand it and train and can train the model on this, right? I would say no, it is quite complicated still. Okay. But why it is complicated now? That would be the question. So I would like to clean the window. Okay. Let me clean this. I just want to explain you why it is still complicated, why it is not recommended to use such kind of indexes. So I would explain that. So ordinal problem was there. Now what is ordinal problem? You must ask me, right? So ordinal problem, I would like to explain you with an example once again. So let's say I'm saying this is apple, whose rank is 0, okay, or whose index is 0, okay. I'm saying banana, that is 1, means its rank is 1, right? I will say cherry, let's say its index value is 2, let's say I'm assuming like that. See, I already mentioned here 0 1 2, right? So if anybody will came across to this data, they will think like banana is better than apple. Why? Because 1 is greater than 0. Okay. And in case of cherry, somebody will think cherry is better than both banana and apple. Why? Because banana is 1 and apple is 0. So these two are lesser than this number. That's why cherry is more dominating, okay, or more better than these two, right? So in that case, a scientist or researcher came across to treat these 3 classes equally. So what they did, they simply introduced one hot encoding concept. Now what it is? So let me give you an example on this. So let's say I have 3 classes, apple, banana, and cherry. Okay, I'm indicating apple by A, banana by B, and cherry by C. All right. So let me create a vector. Okay, because they in machine learning we always use a vector. Okay, means I'm talking about arrays or tensor, you can say also. So for this representation, they used to say like suppose if we are getting apple, okay, apple, let's say I'm getting apple in the very first, okay, very first feature I'm getting apple. Okay, so what will happen in that case? It will simply mention 1 there, means it there is apple, right? That's why I mentioned 1 in the very first feature column. Okay. And for banana it will mention 0, and for cherry it will mention 0. Such kind of vectorization or encoding they perform instead of this 0 1 2, because people start understanding, or machine learning algorithms start understanding like banana is better, cherry is better than banana and apple. So some sort of problems start happening, means our machine learning model on the basis of this value, it start training the model in perfect way. All right. So to cop up that problem, we introduce a kind of concept to represent each vector on equal sense. So here we have, let's say, banana. So in this 3 column, we have banana at the middle section. So I will mention one here, and rest indexes I will make it 0. Okay, because there is no apple, there is no cherry, only banana. So at the place of banana, I mention 1. Similarly with this, okay, with cherry. Okay, so what will happen? So I will simply mention 0, 0, and 1. Now see, each and every vector looking same. There are single values, and that single value is also equal. That is 1. So whenever we pass this matrix to machine learning mathematical algorithm while training a model, it treat them all equally. Okay. So this way, one hot encode solves the problem of ordinality. Okay, or ordinal problem, it's solved by one hot encoding concept. Now the same concept I'm going to teach you by coding now. So let's do coding on this, like how can we do one hot encoding. Okay, so let's say I have a list, or you can say a vector. Okay, a vector of fruit, okay, or fruits. So I'm just creating a variable here. Fruit class is fine, it's looking fine. I will simply mention here, let's say, apple. All right, I will mention here banana, and the third one is cherry. Okay, but the problem is I want to convert them into one hot encoded form. Okay, so first of all, I have to import TensorFlow as TF, because we are learning TensorFlow and I'm going to perform this all operation using TensorFlow only, and that's why I have to import them, right? So I imported this. Okay, so this is TensorFlow I'm using here. Now I want to give this value some indexes. Okay, so assign unique index to all fruit. Okay, all fruits. So how can I do this? So I will again say fruit class index. All right, and for apple, for apple I'm going to assign 0. For banana I'm going to assign 1, and for cherry I will assign, it's a 2. So similarly, I will mention in this, for apple, I'm mentioning 0, for banana, I'm mentioning 1, for cherry, I'm mentioning 2, all right? But what kind of problem we will face? Ordinal problem. Ordinal problem, all right? So ordinal problem is quite dominant in machine learning training, okay? So that's why we have to introduce, to solve it, we introduce one hot encoding. All right. So how can we convert these into one hot encoding using TensorFlow? So I have to simply use TF dot. One hot encode is there as a functionality, or as a function, okay, in TensorFlow. So one hot I have to mention. Let's see. See, I'm getting one hot. And there I have to pass this fruit index. Okay, so fruit index I have to pass this one. Okay, just to convert them into one hot encoding. We cannot pass this directly to the one hot encode. Okay, we have to pass this one. All right, was the I have to assign them unique indexes. So generally it is recommended to start indexing from 0. So I would recommend you to start it by 0 only. Okay, so I mentioned here fruit indexes, which is my variable where I mention all the indexes of the fruit, okay, which is available in this list. All right. So I will simply mention here fruit class index. Then I have to mention depth. Now, what is depth? Depth is how many elements are there in your indexes. Okay. Let's say I have, like, I started indexing from 0, right? 0 to 2. So there are 3 elements, right? Which is started from 0. That is important. Okay, so always keep in mind, if it is started from 0 only, then you have to mention 3 if there are 3 elements. Okay. If there are three elements and started from 0, then only you will mention 3. Okay. If there would be something else than this, let's say 1, 2, and 3. I started indexing from 1. In that case, I have to change it by 4. Okay. So keep this thing in mind. Always start it by 0. Okay. That's why it is recommended. So I'll mention here 3. Okay. And now I'm assigning to a variable fruit class index. And let's say I'm saying 1 hot. Okay. I just want to make it readable. So that's why I just assigned such a huge name. Okay. Because it is readable for me. Okay. So now I want to print this whole value, fruit class index 1 hot, and I will get 1 hot. Okay. Which is in the form of this. So basically, this fruit class, I convert them into 1 hot encoded form. See, this is vector, this is vector, this is vector. Vector definition I already told you, like who has one dimension, means there's only one bracket, okay, at the initial pointer, right? So that's called vector. Okay. If there are more than one square bracket, that means that's matrix. Okay. Or tensor, you can say everything. All right. So now here we are getting tensor. Okay. But that tensor contain vector inside. This is the very first vector, this is second vector, and this is third vector. This vector is for apple. That's why we got 1 at the very first position here. Okay. This is my second vector. Second vector means it's representing banana, on which is available on second index, right? Means 0, 1, 2, right? Such kind of indexing we assigned here. So that's why it is mentioning, like, see, it is looking something like this: apple, banana, and cherry. Okay, apple, banana, and cherry. So where we have apple, it is simply mentioned 1 and rest are 0. Where we are using banana, it is mentioning there 1 and rest are 0. Okay. Where it is mentioning cherry, it is mentioning there 1 and rest are 0. So this is a kind of vector we are getting for each fruit. Okay. And because these are multiple vectors, so we have to enclose them in certain array. So that's why we assigned one more bracket outside and it become a matrix. One hot encoding matrix, or one hot encoded matrix, you can say. So this is the concept of one hot encoding. Now, one hot encoding generally used to give all elements equal indexes before passing to a machine learning or deep learning model for training. Okay. For training. All right. So each class will treat equally. All right. But what happened here? Here, because apple index is 0, banana index is 1, and cherry index is, let's say, 2. So here our machine learning model start thinking like cherry is better than banana and apple, because cherry index is 2, which is greater, which is greater than banana and apple. Why banana and apple? Why it is greater than banana and apple? Because banana index value is 1 and apple index value is 0. So 2 is greater than 1 and 0. That's why cherry is more important feature. Okay, such kind of message detected by machine learning model, right? So that's why we have to introduce one hot encoding. And this problem basically denoted by ordinal problem. There's terminology used by machine learning engineers, ordinal problem. Okay. So simply to resolve this ordinal problem, we use one hot encoding and then we start training our model. So this is all about a machine learning model. I just wrap up with conclusion. Okay, this is conclusion. All right, guys. So this is conclusion for this. Now, so is there any alternate option we have to create one hot encoded vector? Yes, we have. Where? So we have to talk about alternate option. What alternate option we have available? So basically, one alternate option I'm going to suggest, but apart from this, we have a lot of alternate option to use such kind of encoding. So I would like to first of all tell you about a third-party library which we have to download first of all, and that is category encoder. So I have to install that here. Pip install category encoder. All right, I have to install it. Then I can only use it. So basically it is category encoders. All right. So see, I have to install it first of all. Okay. And once I will install it, then I have to import it. So from category encoders, import one hot encoder class. Okay. So I also need pandas library because it will work on pandas. Okay. So first of all, we have to read the data set, data frame, and then we have to pick the column on which we want to apply one hot encoding. So that's why panda is required. So I have to import pandas. If you don't know about pandas, just go to my machine learning playlist. You will get the videos on pandas and you will get aware with these kind of operations on pandas. Okay. And then once you will come back here again, you will able to understand what I am performing here. Okay. So let's say I am creating a data frame. I'm creating a data frame. So I just want to demonstrate a column because I want to apply one hot encoding to, let's say, fruit kind of column. So I'm just giving it a fake name right for now. Okay. And I have to pass this data. Okay. This data here. Okay. In this bracket. Okay. So I need single bracket. Okay. Just remove this. Yeah. And after that, I have to store it like a fruit data frame kind of variable. Okay. Then I have to create a object of this one hot encoded class. So object, I'm just giving it a name object. Okay. One hot, you can give any name. Okay. One hot. And I have to pass like object dot fit underscore transform. Here I have to pass a parameter let me read the documentation, the feature name. Okay. So let's say X is equal to, I'm giving the feature name fruits. Okay. From where I'm getting it. So this is that column on which I want to implement one hot encoding, right? So I will use it here. Okay. And then I have to implement use cat name true. Use cat names true. Okay. Category name it is talking about. Okay. So I have to use category like three kind of category we have available: apple, banana, and cherry. So for that I pass this parameter. Okay. Now I have to assign it to a variable. So I will name it fruit data frame. Let's say one hot. Okay. I will assign it to a variable, which is fruit data frame one hot. Okay. And I will try to see like what kind of matrix I'm getting. So I have to use here numpy functionality and hit shift enter. See, I'm getting one hot encoded data. See, and its data type is float 32. Okay. So this is one hot encoded data. So this is the alternate way you can use. So it is quite easy as compared to category encoders. Okay. So I would request you to use the TensorFlow one hot. Okay. Not to use this. Okay. And this is a kind of alternate I'm talking about. Means if you'll go with a machine learning, deep learning kind of series, or operations or work, you have to simply use TensorFlow there or PyTorch. Okay, so inside that kind of library, it's already given kind of functionality to implement one hot encoding. So no need to use this third-party tool, okay, or a third-party kind of stuff. Okay, it is quite complicated for sure. So let's move to our fourth agenda. So our fourth agenda is execution comparison with other tool. So what is this? So let me make a heading of it. It's totally theoretical for now. Okay. It's talking about execution comparison. Okay. So the means we are comparing its execution with other tools also. So like if I will use this, okay, instead of TensorFlow one hot encoding, what are their comparison? Which one is best? Which one is not good? Okay. So let's see. So I just make a note of it. Okay. From Google. Like if you will use TensorFlow, it is like its pros is efficient and integrates well with TensorFlow models. Okay, you can easily integrate this with TensorFlow models. Okay, like if you will create any kind of machine a deep learning model, you can easily integrate TensorFlow one hot encoding. Okay, with TensorFlow models. Okay, overkill for a sample processing task. Okay, and the application which I told you later on, like this one, okay, this is basically implemented on pandas. That's why I imported this library as well. Okay, so in this, its pros is very straightforward and integrates seamlessly with data frames. So it is very much workable with data frame. Okay, seamlessly integrated with data frame. So we are doing a deep learning kind of operation. So basically, it is not perfect match or perfect fit for a deep learning training. Okay, deep learning model training. Okay, so I would request you not to use this. Okay, but just because I mentioned alternate options, that's why I had shown you this pandas operation, which was this categorical encoder. Okay, so I would request you not to use this. It's basically you have to create data frame. A lot of stuffs are there. See, you have to create data frame first, and then you have to pass that data frame column name, and then you have to pass your values which you want to encode. Okay, one hot encode. So it's quite long. Okay, so yeah, this is it in this section. Now the conclusion. I already told you the conclusion. I'm once again demonstrating it. What is conclusion? Okay, so one hot encoder help to solve ordinal problem. Ordinal problem. So ordinal problem, basically I told you, let's say Apple is on 0th index, means Apple, I said this is 0th class. Okay, banana, I said, let's say one class. Cherry, let's say I said two class. So machine learning model or deep learning model start thinking like this is better, means 2 is better than 1 and 0 because 2 is bigger, right? So that means cherry is better than apple and banana, and machine learning model or deep learning model start focusing on this more as compared to these two. Okay, similarly banana is better than, means 1 is better than 0, right? Because 1 is greater value than 0. So again, deep learning or machine learning models start focusing on this. Okay, so to solve this problem, we start creating uh, some sort of encoding. Okay, to assign them equal value to each and every class. Okay, and we call each and every column, like this is apple column. If any feature belongs to apple, we have to simply mention 1. Okay, this is my first feature column. So suppose if any value belongs to apple, I have to simply mention 1. Okay, if there is no apple, I will simply mention 0. Okay, and because in first feature I get apple, I mention 1 and remaining should be 0, because this class, this column belongs to banana and this column belongs to cherry. Okay, so this is conclusion. To solve this ordinal problem, we simply use one hot encoding, and this is the conclusion here. Okay, so I can simply mention here, to remove ordinal problem, we implement one hot encoding. Okay, the second point we can mention here, machine learning model or deep learning model work on mathematical equation or algorithm. So number dissimilarity is not acceptable. Hence, to make each number equal, use one hot encoding. And that's it. So hope you guys like this video. If you really like this channel, like this video, please share with your friend, family, and colleagues. And please stay tuned with this channel. I will definitely upload a lot of videos on this. So if you have any problem, any query related to the stuff which I'm delivering here, you can comment me. You can also join me on Instagram, on WhatsApp group, or on Telegram. Okay. So there are all links in the description. You have to simply go there and you have to click on the link. You will definitely get in touch with me. All right. So thank you very much, guys. Thank you once again and take care.